Welcome to my DSP lecture video series 7. Here I introduce linear transformation matrix in term of IDFT. As we know, the formula of IDFT as a linear transformation matrix, that is small xn equals to capital W minus kn into capital N, capital Xn. Now here we write down the generalized formula for capital W minus 1n, which is, before writing the matrix formula, we first write 1 by n, then we write down the matrix. And the interesting part here, you see the formation of matrix are similar with DFT matrix. The difference only here we consider the minus sign in capital W power. Now, in case of n equals to 4, we write down 1. Before we write down the matrix, we write down 1 by 4. Then we write down the total factor, and after that we write down the value of the total factor. And the difference between the DFT and IDFT matrix, that part is the imaginary part, which is called complex conjugate. Now here compute 4-point IDFT of a sequence capital XK 1010 value. Similar way to write down the matrix and multiply with the matrix of 1010 as matrix multiplication method, and finally we get the result small x4 equals to 0.5, 0, 0.5 and 0. This is the some problem statement of IDFT using linear transformation matrix. Thank you. Welcome to my online lecture series 8. Here I introduce multiplication of two DFTs component method we follow here, that is circular convolution. Several methods are present for finding the circular convolution result. In this lecture series, I introduce graphical method to solve the circular convolution. Before starting circular convolution, here I discuss about multiplication of two DFTs component. Here I assume that I have two time domain discrete signal as small x1n and small x2n. Firstly, I convert the signal from time domain to frequency domain. Reason earlier I discussed in detail. So, doing n-point DFT, I got capital x1k and capital X2k signal. Now we perform multiplication of those frequency domain signal. Then again doing endpoint IDFT of new frequency domain, that is capital X3k signal, and finally we get new time domain signal as a small x3n. The procedure we call circular convolution. If we elaborate the DFT equation separately and then multiplying the component and applying modulo arithmetic, finally we get small x3m equals to summation n 0 to capital N minus 1 x1n x2 modulo n m minus n. So this is formula of circular convolution. Double bracket symbol represent mod. Now you see most interesting part of the convolution, that is linear convolution formula. The difference between two, that means difference between circular and linear convolution. For circular, the modulo sign is present. Later on we discuss the relation between linear circular convolution and the noted thing modulo part solved by circular way. Now we try to solve some problem using graphical method. Now here the sequence length in both cases, that is 4, means capital N varies from 0 to 3. Now again we elaborate the basic formula, that is x30 equals to summation small n 0 to 3 small x1n small x2 modulo minus n 4. Then again elaborate the formula. We can write x30 equals to x10 multiply with x2 modulo minus 0 plus x11 multiply with x2 modulo minus 1 plus x12 multiply with x2 modulo minus 2 plus x13 multiply with x2 modulo minus 3. So here we take two sequence in circular form. So first we draw a circle, the divided with 4 points, because we already know n equals to 4. For first and second sequence, extreme right of the x-axis we take as x10 and x20 point. Then next point consider as anti-clockwise and establish all other points accordingly. to the picture. Now, as per the last slide, that is elaborate formula of circular convolution, we done folded version of second sequence. That means x20 and x22 point position are fixed and other two position are interchange. That means topmost position consider as x23 in place of x21 and another point is x21 in place of x23. Here we can also say modulo minus n means point position considered as clockwise for first time of the second sequence. As you know, for product sequence we multiply the normal first sequence with folded version of the second sequence. Now we get point to point multiplication. After we get 2, 4, 6 and 2 value, and as per the formula we add all the point and we get finally x30 value, that is 14. Now in this slide find out x31 value. Same process here, we consider take first sequence same as previously, then consider folded version of the second sequence. As per the formula for the second sequence, consider as x2 modulo 1 minus n 4. That means second sequence of the folded version with direction with rotation anti-clockwise direction by 1 unit in time. Now the point considered as starting from x21, x20, x23 and x22. Now for the product sequence we get 4, 1, 8, 3 simultaneously after point to point multiplication, and finally after all 4 value addition we get x31 value, that is 16. Now for the next slide, here again find out value of x32. Same process here, we consider take first sequence same as last two cases, then considering the second sequence of folded version with rotate anti-clockwise direction by 2 unit as per the formula. That means x2 modulo 2 minus n 4. Now the point considered as x22, x21, x20 and x23. Now for product sequence, if we consider, we get 6, 2, 2 and 4 value after point to point multiplication, and finally after all 4 value addition we get x32 value, that is 14. Lastly, in this case find out x33 value. Same process here, I consider take first sequence same as last 3 cases, then second sequence of folded version with rotate anti-clockwise direction by 3 unit as per the formula. That means x2 modulo 3 minus n 4. Now to point consider as x2 3, x2 2, x2 1 and x2 0. For final product sequence we get 4, 3, 8, 1 value after point to point multiplication, and the final after all 4 value addition we got x3 3 value, that is 16. So finally doing the circular convolution using graphical method we get x3n as result, that is 14, 16, 14, 16. Thank you. Welcome to my online lecture video series 9. Here I introduce multiplication of two DFTs component method I follow here, circular convolution by matrix multiplication method. Using matrix multiplication method to solve the circular convolution. As same example here we consider to solving the circular convolution, but the method here consider, that is matrix multiplication method. Before solving the problem, first know the digital generalized algorithm we discuss. Here we consider two matrices. As you know, first sequence are fixed and we operate the second sequence. Same method here I consider. Here first matrix consider for small x2n sequence column wise. In the top of the matrix we write first sequence and the consider others. In the slide first sequence is x20 and then x21, x22 up to consider x2 capital n minus 1 and x2 capital n minus 2 sequence. Then move to second column of the second sequence. Rotate by 1 row shift with x2 capital n minus 1. Then we write x2 0, x2 1 up to x2 capital n minus 3 and x2 capital n minus 2. Similarly, we done the rotation depend on capital N. If capital N is 4, the size of the matrix 4 cross 4, that is row into column. For first sequence we directly write in one column like x10, x11, x12 up to x1 capital N minus 2 and x1 capital N minus 1. Again n equals to 4. Then the size of the matrix considering 4 cross 1, that is x10, x11,
x1 2 and x1 3. The matrix multiplication of two matrix, we get output result in form of small x3 n. In this case, n equals to 4. Now we make the first and second matrix according to the previous slide. Here also see the multiplication part, then we get the final result also. Now I consider the problem statement. Basis on the previous slide, in first we rotate the sequence in column wise. And then perform the multiplication with first sequence. Here you see how to multiplication is done, and finally we get the result as 14 16 14 16. Thank you. Welcome to my online lecture video series 10. Here I introduce again multiplication of two DFTs component, but the method we follow here DFT IDFT method. So using DFT IDFT method we find out the result of circular convolution. So again considering same mathematical example for solving the circular convolution, before starting the method, firstly we introduce the method as early described. Here I assume that I have two time domain discrete signal as small x1n and small x2n. Firstly, I convert the signal from time domain to frequency domain signal. Reason earlier I discussed in detail. So doing endpoint DFT, I got capital X1K and capital X2K signal. Now we perform multiplication process of those frequency domain signal, then again doing endpoint IDFT for new frequency domain signal, that is capital X3K signal, and we get new time domain signal as a small x3n. The procedure we call circular convolution. Method we follow DFT IDFT method. For individual case, first we write phase part, that is total factor base n by n DFT matrix, and then x1 sequence, and we get the result of first sequence, and method followed for also for the second sequence. That is case of x2. Now we get a result for capital X1 6020 and for capital X2 10 minus 2 plus 2j minus 2 minus 2 minus 2j. Then we perform the multiplication of those frequency domain signal and we get new frequency domain signal, that is x3k. Multiply the component wise multiplication and we get the result 60 minus 4 0. Then as per the method we already told, we found n by n IDFT matrix calculation and we get final result, that is 14 16 14 16. Thank you.